With the velocity time graph, we've got the velocity on this axis and time on this axis. There's two key things we need to remember about it. First of all, the gradient of the curve is the acceleration. All right, that's the first thing to remember. And the distance is found by the area underneath the curve. So if we do the acceleration first, right, it says the acceleration of the particle is 0 when t is equal to. So we've got to remember now how we actually find the acceleration, and we basically do it by drawing a gradient, right? A tangent, sorry, and finding the gradient of that tangent. The point where the acceleration is 0, right, is at that point there, which is called a turning point. So that's the point that they're talking about. So on mine, it's about 2.3 seconds. All right. The second part where then says, find the acceleration when t is equal to 1. Okay, so to do that, I go to the point t is equal to 1, and I've got to draw a tangent at that point. Okay, so a tangent is a line which just touches the curve. So there's a little bit of leeway given for it, but that's the tangent that I've drawn in, so it's just touching it at that point. I work out the gradient of that straight line now by basically picking 2 points, going between them and working out the up divided by the across. Alright, so that point there is a point 1, 1, and I've got a point there which is a point 3 and what's that, about 3.5. As I go between the 2 points, I essentially make up a little right angle triangle. Right, and the gradient is the up divided by the across. Right, so I've gone from 1 to 3 in time, so my cross is 2, and I've gone from 1 to 3.5, so I've gone up 2.5. So that's why the acceleration then is 1.25, and the units of it are meters per second. Okay, squared. To do the second part of the question, which is find the distance travelled, right, that's actually found by finding the area underneath the curve. Now to do that, I've naturally got the curve split up into what is essentially, if I draw lines down from there, the values across the bottom are telling me or suggesting to go across in ones. Right, so if I drop my line from those points there, I've landed up with A, B, C and D areas. I'm going to join the top points together, so rather than having a little part of a curve on the edge of them, I'm going to basically make it into some sort of a straight line shape. Now we can see in this case, right, I've got this big part of area at the top of the diagram, right, which isn't actually going to be included in this, but we just have to ignore that basically. I've now got 1 triangle and 3 trapeziums. I find the area of each one of these shapes, I add them together, that gives me the total distance travelled, which is, the total area, which is the total distance travelled. Okay, I've written in the heights of each one of these straight lines now, which are the y coordinate of those points. So I'm now going to just add my bits together. So area A is a triangle, which is 1 wide and 1 tall. So that's a half. B is a trapezium, where I add the parallel sides together and times by the distance between them. I'm going to do the same for C. And I'm going to do the same for D. So D and C actually land up being the same size. When I add them together, my total area is 7, 9. So I've got 9.5, and that would be meters travelled, because that's the total distance. Okay, enjoy everyone.